Quadratic application number 8. The manufacturing of a metal box start with a rectangular sheet of metal that is 3 times as long as it is wide. So that's going to be 3x and 2x. And x. 4 equal squares are cut from the 4 corners, and the flap of each corner is turned up to form a box that is 2 inches high and is open on the top. What should be the width of the rectangular sheet of metal in order for the box to have a volume of 102 cubic inches? Okay, this is a little bit different in that you don't have a constraint and objective because your constraint is already in your picture. So I'm going to draw a couple pictures here, and then I know you have a blank sheet underneath. We can do the work. First of all, I'm going to draw a rectangular shaped box. Okay, you're going to have a box here, and the box is going to be open. All right, and they said it's 2 inches high. So basically, you're trying to figure out what, and they said that one side of this sheet of metal is 3 times longer than the other side, but it doesn't mean that's what the length of the box is. That's just what the box is going to look like, and we know it's going to be 2 inches high. The rectangular sheet of metal that it comes from, it looks like this. Okay? Here's a flat metal, and if you can actually see this, is what you do is you're going to cut out of the corners 2 inches. So this is 2, 2, 2, 2. I don't know if you're going to visualize this, so let's try this. And what you do is you're going to kind of fold it along here, fold it, fold it, and fold it. And when you do, this will tip up. Okay, this will tip up. This will be gone. The corners will be gone. So this is going to be gone. This is going to be gone. And you're going to see you're making an open box if you can visualize this turning up, this turning up, this turning up, and this turning up. So it's going to look kind of like that picture right there. It's going to have an open box. Now they did say that this sheet of metal is 3 times longer than it is wide. So here's my width and here's this. Alright. Now if we're going to do the algebra with this, you know it has to have a volume of 102 cubic inches, and you know the volume formula is length times width times height, but of the box. So if I were to fold this piece right here, okay, I'm going to change the colors on it a little bit. This piece right here and this piece right here, okay, so this is the base of your new box, is going to be shorter. Well, how much shorter? Well, if this whole side's x and this is gone and this is gone, this is really x minus 4. If you look at this side, this whole side is 3x, but if I take away this and this is really 3x minus 4. So this is the new base of my box. So this is really x minus 4 here, and this is 3x minus 4, and it's too high. Okay? 2 inches high. So now we can actually come up with a formula. So I'm going to move this down a little bit, and so I can have more white space to draw. So here's my volume is length times width times height. So it's going to be the height is 2 times the length times the width. And we know the volume has to be 108. So I am going to multiply this all out first before I put the 108 there. So this is going to be 2. I can multiply these two together. So I have 3x squared minus 12x minus 4x plus 16. So now the volume is 2 times 3x squared minus 16x plus 16. Multiply these by 2 again. Oh, excuse me, I might as well just distribute it now. So I have 6x squared minus 32x plus 32. Now I'm going to put the 108 right in this spot because I know that's what the volume of my new box is. So remember, all these are the shortened sides. This is one side, the other side, and this is how high it is. So I have 108 equals 6x squared minus 32x plus 32. Now I'm actually going to find x. I need to find what the value of x is. So I'm going to move the 108 over here. So I end up with a 6x squared minus 32x, and if I subtract 108, because I'm moving it on this side, minus 70 equals 0. So here's my new equation. So now I just got to solve for x. So the first thing I did was I want to make this easier on myself, so I'm going to factor out a 2. So I have 3x squared minus 16x minus 35 equals 0. I have 2, and I'm going to see if this is factorable. I'm sure it is. So you can split the middle or do whatever you have to do to factor this, but you know it's going to be 3x and x. And then you can either, some people are good at guessing and checking or splitting the middle. It doesn't matter. Either way you do it, this is what it comes out to be when you factor it. Now I'm going to draw my big T. Well, it's actually a couple of here. First of all, 2 will never equal 0, so you say, thanks for playing, but I don't need you anymore. 3x plus 5 equals 0. X minus 7 equals 0, so x will equal 7. This one is 3x equals negative 5, x equals negative 5/3. Because we're talking about a box, this we reject because you can't use a negative for a box. So basically we're saying x is 7. Well, we're in our picture, where is x 7? Well, right here, this is 7, and I know this is 21. So what should the width of the rectangular be? It should be 7, and this is inches, and 21 inches. So the box is really 7 by 21 inches. Not the box, but the rectangular sheet, in order to make a box that has a volume of 102.